As we approach the facility, we're greeted by a sea of white boxes stretching as far as the eye can see. These are the beehives, each one a bustling metropolis of up to 60,000 bees. The hives are strategically placed to maximize access to nearby flowering plants while providing enough space for the bees to thrive. Each hive is a marvel of natural engineering. Inside, you'll find a series of frames where bees build their honeycombs. These hexagonal wax cells serve multiple purposes. They're nurseries for developing bees, storage units for pollen, and most importantly, the place where nectar is transformed into honey. Maintaining thousands of hives for large-scale production is no small feat. The sheer number of colonies presents a unique challenge for beekeepers. They must constantly monitor the health of each hive, manage pest control, and ensure the bees have access to sufficient food sources throughout the year. It's a delicate balance of nurturing the bees while meeting the demands of commercial honey production. At the heart of this operation are the worker bees. These industrious insects are responsible for collecting nectar from flowers and bringing it back to the hive. As a worker bee visits flowers, it uses its long tube-shaped tongue called a proboscis to suck up the nectar. This nectar is stored in the bee's honey stomach, separate from its regular stomach. During the flight back to the hive, enzymes in the honey stomach begin to break down the complex sugars in the nectar into simpler sugars. Once back at the hive, the worker bee regurgitates the nectar, passing it to other worker bees. These bees continue to pass the nectar from bee to bee, further breaking it down and removing moisture. The partially processed nectar is then deposited into the honeycomb cells. The bees fan their wings, creating airflow that evaporates more water from the nectar, thickening it into honey. Once the honey reaches the right consistency, the bees cap the cell with a thin layer of wax, sealing it for future use. The types of flowers the bees visit play a crucial role in determining the honey's flavor profile. This facility strategically places its hives near diverse floral sources to produce a range of honey varieties, from the light, delicate taste of clover honey to the rich, robust flavor of buckwheat honey. Each type reflects the unique nectar composition of different flowers. As we delve deeper into the hive's inner workings, you might wonder just how many bees it takes to produce a single bottle of honey. The answer is staggering. It takes the lifetime work of approximately 768 bees to make just 1 pound of honey. When you consider that the average worker bee only lives for about 6 weeks during the busy summer season, the scale of this operation becomes even more impressive. This brings us to the next stage of honey's journey. Once the bees have done their part, filling the combs with ripe, capped honey, it's time for human intervention. The beekeepers must now carefully remove the honey-filled frames from the hives without disturbing the bees' delicate ecosystem. This process, known as harvesting, is where the beekeeper's skill and modern technology come together to efficiently collect the honey while ensuring the bees' continued well-being. As we transition from the natural wonder of the hive to the human-driven harvesting process, we'll see how beekeepers have refined their techniques to maximize honey production while respecting the incredible creatures that make it all possible. Beekeepers face a daunting challenge: removing honey from thousands of hives while keeping millions of stinger-equipped workers calm and unharmed. It's a high-stakes ballet of smoke, protective gear, and split-second decisions. But there's a secret technique that turns this potential nightmare into a smooth operation. At the world's largest honey production facility, harvesting is an art form perfected by expert beekeepers. These skilled professionals understand that the key to successful harvesting lies in the delicate balance between efficiency and bee welfare. Their goal is to collect the honey without disrupting the hive's intricate ecosystem or harming a single bee in the process. The harvesting process begins with careful timing. Beekeepers monitor the hives closely, waiting for the right moment when the honey is fully ripened and the honeycombs are capped with wax. This usually occurs in late summer or early fall when the bees have stored enough honey for the winter. Harvesting too early can result in unripe honey with high moisture content, while waiting too long might leave the bees without sufficient winter stores. As the beekeepers approach the hives, they don their protective gear: full body suits, gloves, and veiled hats. This equipment is essential for safety, allowing the beekeepers to work confidently around thousands of potentially defensive bees. The first step in the harvesting process is to calm the bees, and this is where the beekeeper's secret weapon comes into play: smoke. Using a specially designed smoker, beekeepers puff small amounts of smoke into the hive entrance and around the frames. The smoke has a fascinating effect on the bees. It masks the alarm pheromones that bees release to signal danger to the colony, effectively keeping them calm. Additionally, the smoke triggers a feeding response in the bees, causing them to gorge on honey in preparation for a potential hive relocation. This makes them less likely to sting and more docile during the harvesting process. With the bees calmed, the beekeepers carefully remove the outer cover of the hive and begin to inspect the frames. They're looking for frames that are at least 80% capped with wax, indicating that the honey inside is fully ripened. Using a specialized tool called a hive tool, they gently pry apart the frames, breaking the propolis seal that bees use to glue everything together. The selected frames are then carefully lifted out of the hive. Here's where modern technology comes into play. Instead of shaking or brushing the bees off the frames, which can be stressful for the insects, many large-scale operations use bee blowers. These devices gently blow the bees off the frames and back into the hive, minimizing disturbance and reducing the risk of injury to the bees. Once cleared of bees, the honey-laden frames are placed into transport boxes. These boxes are designed to keep the frames secure and prevent robber bees from other colonies from accessing the exposed honey. The removed frames are quickly replaced with empty ones, allowing the bees to continue their work without interruption. One of the most efficient methods used in large-scale operations is the checkerboarding technique. This involves removing every other frame of honey and leaving the rest. This method not only speeds up the harvesting process, but also encourages the bees to quickly fill the empty spaces, potentially allowing for multiple harvests in a single season. Throughout the entire process, beekeepers maintain a keen awareness of the hive's condition. They check for signs of disease, ensure the queen is present and healthy, and verify that the colony has enough honey left for their own needs. This holistic approach to harvesting ensures the long-term health and productivity of the hives. As the last frame is carefully packed away, we see the true artistry of the beekeeper's craft. They've managed to collect hundreds of pounds of honey without harming a single bee or disrupting the delicate balance of the hive. It's a testament to the harmony that can exist between human industry and nature's ingenuity. With the harvesting complete, the honey-filled frames are now ready for the next stage of their journey. They'll be transported to the extraction room, where the golden liquid will be separated from the wax comb. As we move from the open fields to the controlled environment of the processing facility, we'll discover how modern technology takes over to turn these frames of capped honey into the pure, flowing sweetness we recognize on our store shelves. You might think that once honey is harvested, it's ready for your toast. But there's a crucial step between hive and home that few people ever see. In the next few minutes, we'll reveal the most efficient method for extracting honey, one that processes thousands of combs daily while preserving every nuance of flavor. Are you ready to uncover the secrets of industrial-scale honey extraction? Welcome to the extraction room, the beating heart of our honey production facility. This climate-controlled space is a hive of activity, filled with gleaming stainless steel equipment designed for one purpose: to separate pure honey from the wax combs as efficiently as possible. The air hums with the sound of machinery, and the sweet aroma of honey permeates every corner. The challenge facing our extraction team is formidable. They must process thousands of honey-filled frames each day, extracting every possible drop without compromising the quality or unique characteristics of each honey variety. Speed is crucial, but so is precision. Any misstep could result in wasted honey, or worse, a degradation in flavor or purity. At the center of this operation are the extraction machines, marvels of engineering that use centrifugal force to draw honey from the combs. These massive cylindrical devices can hold dozens of frames at once. As the extractor spins, honey is forced out of the comb cells and collects at the bottom of the machine. The process begins as workers carefully load honey-filled frames into the extractor. They arrange the frames like spokes on a wheel, ensuring even weight distribution for smooth operation. Once loaded, the machine begins to spin, slowly at first, then gradually increasing in speed. The centrifugal force created by this spinning motion pulls the honey out of the comb cells and against the walls of the extractor. As the speed increases, a cascade of golden honey begins to flow down the sides of the extractor. It's collected at the bottom and pumped through a series of filters to remove any wax particles or other debris. The extracted frames, now empty of honey but with their wax structures intact, are set aside to be returned to the hives. This preservation of the wax comb is crucial, as it allows the bees to immediately resume honey production without expending energy rebuilding their storage cells. One of the most impressive aspects of this facility is how it maintains the integrity of different honey varieties. Not all honey is created equal, and preserving the unique flavors and properties of each type is paramount. To achieve this, the extraction room is divided into sections, each dedicated to a specific honey variety. This segregation ensures that the delicate floral notes of orange blossom honey, for example, aren't mixed with the robust flavors of buckwheat honey. The efficiency of this process is staggering. A single large extractor can process hundreds of frames in an hour, yielding gallons of pure honey. But speed isn't everything. The extraction team constantly monitors the process, adjusting speeds and times to account for variations in honey viscosity, which can change based on factors like temperature and floral source. As we watch this mesmerizing process, you might wonder about the most efficient method for extracting honey on this massive scale. The answer lies in a combination of cutting-edge technology and time-tested techniques. The centrifugal extractors, with their ability to process multiple frames simultaneously while preserving the wax comb, remain the gold standard in large-scale honey production. However, the true efficiency comes from the seamless integration of these machines with automated uncapping systems, honey pumps, and filtration units. This integrated system allows for a continuous flow of honey from frame to storage tank, minimizing handling and exposure to air, which could affect the honey's quality. It's a process that can extract and filter thousands of pounds of honey in a single day, all while maintaining the distinct characteristics of each honey variety. As the last drops of honey are pumped from the extractors, we've witnessed the transformation of honeycomb into flowing, pure honey. But our journey isn't over yet. The extracted honey, while free from wax and debris, still needs further refinement before it's ready for bottling. As we move to the next stage of processing, we'll discover how this golden liquid is filtered and prepared for its final journey to your table. As our extracted honey flows towards its next destination, a question arises. How do you maintain the purity of nature's perfect food when processing it by the ton? The answer lies in a filtration process so precise, it can remove particles smaller than a human hair while preserving every nuance of flavor. Are you ready to discover the invisible barrier between raw honey and the bottle on your shelf? Welcome to the filtration room, where honey undergoes its final transformation before bottling. This stage is crucial in commercial honey production, ensuring that every jar meets the highest standards of purity and quality. The challenge here is monumental: to remove even the tiniest impurities without altering the honey's natural properties, flavor, or nutritional value. As we enter the room, we're greeted by an array of sophisticated equipment. Gleaming pipes and tanks stretch across the floor, connected by a network of valves and filters. The air is thick with the sweet aroma of honey, a reminder of the natural product at the heart of this high-tech process. The filtration journey begins with a simple yet effective step: straining. The extracted honey passes through a series of increasingly fine mesh screens, each designed to catch larger particles like bits of wax, pollen, or bee parts that may have made it through the extraction process. This initial straining removes the most visible impurities, preparing the honey for more refined filtration methods. But the real magic happens in the next stage, where advanced filtration techniques take center stage. One of the most common methods used in large-scale production is pressure filtration. Here, honey is forced through a series of fine filters under high pressure. These filters can remove particles as small as 1 micron. That's about 1/70th the diameter of a human hair. The filtration system is carefully calibrated to remove unwanted particles while allowing beneficial components like enzymes and some pollen to pass through. This delicate balance is crucial for maintaining the honey's natural properties and meeting regulatory standards for purity. As we watch the honey flow through the filtration system, it's fascinating to see how it impacts the texture and appearance of the final product. The honey emerging from the filters is clearer and more uniform in color than when it entered. This consistency is essential for commercial production, where consumers expect a standardized product every time they open a jar. However, filtration is not without its controversies. Some argue that excessive filtration can remove too much pollen, potentially making it difficult to trace the honey's origin. To address this concern, Many producers opt for a balanced approach, using filtration methods that remove impurities while retaining enough pollen to maintain the honey's provenance and nutritional benefits. Throughout the filtration process, quality control technicians continuously monitor the honey's characteristics. They perform regular checks on viscosity, moisture content, and color to ensure the filtration isn't altering the honey's fundamental properties. Any deviation from the expected parameters triggers an immediate adjustment to the filtration process. As we near the end of the filtration stage, you might wonder about the secret to maintaining honey's purity during mass production. The answer lies in a combination of cutting-edge technology and rigorous quality control. By using precision filtration methods and constant monitoring, producers can remove unwanted particles while preserving the essence of what makes honey unique. The filtered honey now flows into large holding tanks, ready for the next stage of its journey. As it moves on to blending and packaging, we can appreciate the intricate process that has transformed raw honey into the pure, golden liquid we recognize on store shelves. Every jar of honey is a testament to the delicate balance between nature's creation and human ingenuity. As we leave the filtration room, our honey is one step closer to its final destination, but there's still more to its journey. Next, we'll explore how this carefully filtered honey is blended to create consistent flavors and textures, ensuring that every bottle tastes just as sweet as the last. Imagine tasting 2 jars of honey from opposite ends of the production line. Would you be able to tell them apart? The next stage in our journey reveals the intricate process that makes this question nearly impossible to answer. Welcome to the blending room, where art meets science in the quest for consistent flavor. As we enter this spacious area, we're greeted by the sight of enormous stainless steel tanks, each holding thousands of gallons of honey. This is where the magic of blending happens, a crucial step in ensuring that every bottle of honey tastes the same, regardless of which hive or flower it originally came from. The challenge facing the blending team is immense. They must take honey from thousands of different hives, each with its unique flavor profile, and create a uniform product that meets consumer expectations. It's a delicate balancing act that requires both expertise and technology. At the heart of this process is a deep understanding of honey's characteristics. The blending team considers several factors when crafting their perfect mix. Color is one of the most visible aspects, ranging from light amber to deep golden hues. Taste is, of course, paramount, with flavors varying from delicate and floral to rich and robust. The honey's origin also plays a role, as different regions and flower sources contribute unique qualities to the final product. To achieve consistency, the facility employs a combination of sensory analysis and advanced technology. Trained tasters, much like sommeliers in the wine industry, sample honey from different batches. They assess characteristics such as sweetness, acidity, and specific flavor notes. This human touch is crucial in maintaining the nuanced flavors that consumers love. Complementing the human expertise is an array of high-tech equipment. Spectrophotometers measure the honey's color with precision, ensuring visual consistency across batches. Gas chromatography machines analyze the chemical composition of the honey, helping to identify and quantify various compounds that contribute to its flavor and aroma. The blending process itself is a carefully choreographed operation. Different honey varieties are pumped into a large blending tank in precise ratios determined by the blending team. As the honeys mix, the tank's contents are continuously circulated to ensure thorough blending. Throughout this process, samples are taken and analyzed to make sure the blend is meeting the desired specifications. One of the most fascinating aspects of this stage is how the facility adapts to natural variations in honey production. Seasonal changes, weather patterns, and even the health of bee colonies can all affect the characteristics of the honey produced. The blending team must constantly adjust their formulas to account for these variations, ensuring that the final product remains consistent year-round. As we watch the blending process unfold, you might wonder how this facility manages to create a consistent flavor across thousands of bottles. The secret lies in their meticulous approach to batch creation. By carefully selecting and combining honeys from different sources, they can balance out variations and create a standardized product. It's a bit like a chef adjusting a recipe to account for differences in ingredients, but on a massive scale. The result of all this effort is a product that consumers can rely on. When you pick up a bottle of honey from the store shelf, you can be confident that it will taste the same as the last bottle you bought. regardless of when or where it was produced. As the newly blended honey flows out of the mixing tanks and towards the next stage of production, we can appreciate the complex process that goes into creating this seemingly simple product. The journey from hive to bottle is far from over, though. Next, we'll explore the rigorous quality control measures that ensure every batch of honey meets the strict standards set by both the industry and consumers. Get ready to discover the final hurdles this golden liquid must overcome before it can grace your breakfast table. You might think that once honey is harvested and blended, it's ready for your toast. But there's a gauntlet of tests this amber nectar must pass before it can be called pure. What's the one quality control measure that catches most people off guard? The answer lies in the most challenging aspect of large-scale honey production: ensuring absolute purity and consistency in every single jar. Welcome to the Quality Control Lab, the final checkpoint in our honey's journey from hive to home. This sterile, high-tech environment is a stark contrast to the natural world of the beehive, yet it's crucial in maintaining the integrity of nature's sweetest creation. Here, a team of dedicated scientists and technicians work tirelessly to ensure that every batch of honey meets the strictest industry standards. The complexity of this task cannot be overstated. Honey, despite its simple appearance, is a remarkably intricate substance. Its composition can vary widely depending on factors like floral source, climate, and even the health of the bee colonies. Add to this the enormous scale of production at this facility, and you begin to understand the magnitude of the quality control challenge. As we enter the lab, we're immediately struck by the array of sophisticated equipment. Refractometers, spectrometers, and chromatographs line the benches, each playing a vital role in analyzing our honey. The first test every batch undergoes is a moisture content check. This is crucial because excess moisture can lead to fermentation, compromising the honey's quality and shelf life. Using a digital refractometer, technicians ensure that the water content is below 18.6%, the industry standard for preventing fermentation. Next comes one of the most surprising tests: pollen analysis. Using high-powered microscopes, specialists examine the pollen grains present in the honey. This not only helps verify the honey's floral source, but also serves as a geographical fingerprint, confirming its origin. It's a painstaking process that requires extensive knowledge of botany and a keen eye for detail. But the tests don't stop there. The honey undergoes rigorous chemical analysis to detect any traces of antibiotics, pesticides, or other contaminants. Gas chromatography and mass spectrometry machines work in tandem to identify even the smallest amounts of unwanted substances. This level of scrutiny is necessary to meet international food safety standards and ensure consumer health. One of the most challenging aspects of quality control is detecting adulteration. Some unscrupulous producers might attempt to cut costs by adding sugar syrups or other sweeteners to their honey. To combat this, our facility employs nuclear magnetic resonance (NMR) technology. This advanced method can detect even the most sophisticated attempts at adulteration by analyzing the honey's molecular structure. Throughout these tests, technology plays a crucial role. Automated sampling systems ensure that representative samples are taken from each batch. Computer systems analyze and cross-reference data from multiple tests, flagging any anomalies for further investigation. This integration of technology not only increases efficiency, but also reduces the margin for human error. Despite all this technology, the human element remains irreplaceable. Experienced quality control specialists conduct sensory evaluations, assessing the honey's color, aroma, and taste. Their trained palates can detect subtle variations that even the most advanced machines might miss. As we near the end of our tour through the Quality Control Lab, we arrive at the most challenging aspect of large-scale honey production: maintaining consistency across enormous volumes while adapting to natural variations. Each year brings different weather patterns, varying bloom times, and shifts in bee behavior. The quality control team must constantly adjust their parameters and methods to account for these changes, while ensuring that the end product remains consistent with consumer expectations. With the final tests complete, our honey is ready to move on to the packaging phase. As it leaves the lab, we can appreciate the incredible journey it has undergone. From the natural wonder of the beehive to the scientific precision of the Quality Control Lab, every step has been carefully managed to bring you the purest, highest quality honey possible. The next time you drizzle honey on your morning toast, you'll know the extraordinary effort that went into ensuring its quality and purity. Now that our honey has passed the rigorous quality control tests, you might assume it's ready for your kitchen. But there's still one crucial step remaining. Have you ever wondered how long it actually takes for honey to travel from the hive to your local store shelf? The answer might surprise you, and it all hinges on the intricate packaging process we're about to explore. Welcome to the packaging floor, where our carefully processed honey transforms into the familiar bottles and jars you see on store shelves. This stage plays a vital role in preserving the honey's quality and ensuring it reaches consumers in perfect condition. The air here is thick with the sweet aroma of honey, and the rhythmic sounds of machinery fill the space. The challenge facing the packaging team is twofold. They must bottle honey quickly to meet production demands, while also maintaining its delicate properties. Honey is hygroscopic, meaning it can absorb moisture from the air, which can lead to fermentation if not properly sealed. Additionally, exposure to heat and light during the packaging process can degrade the honey's quality. Balancing speed with preservation is a delicate dance. At the heart of this operation are the automated bottling lines, marvels of modern engineering capable of filling thousands of containers per hour. As we watch, a steady stream of empty bottles moves along conveyor belts, each one precisely positioned for filling. Overhead, large tanks hold the blended honey, keeping it at the optimal temperature for bottling. The filling process itself is a sight to behold. As bottles pass beneath the filling stations, precise amounts of honey are dispensed into each container. The speed is impressive, yet the accuracy is remarkable. Each bottle receives exactly the right amount of honey, measured down to the gram. But not all honey containers are created equal. This facility packages honey in various forms, from squeeze bottles to glass jars, and even single-serve packets. Each type requires a slightly different approach. For example, glass jars are often filled at a higher temperature to allow the honey to settle and release any air bubbles before sealing. Plastic squeeze bottles, on the other hand, are filled at a lower temperature to prevent deformation of the container. After filling, the containers move to the capping station. Here, lids are automatically applied and secured, creating an airtight seal that will preserve the honey's freshness for months or even years. For some premium products, an additional tamper-evident seal is applied, providing consumers with extra assurance of product safety. As we near the end of the packaging line, a sense of anticipation builds. We've followed our honey from the hive through extraction, filtration, blending, and quality control. But the question remains, how long does this entire process take? The answer is both impressive and surprising. From the moment a beekeeper removes a frame from the hive to the time a bottle of honey is placed on a store shelf, the process typically takes between 2 to 4 weeks. This timeline can vary depending on factors such as production volume, specific quality control requirements, and distribution logistics. It's a testament to the efficiency of modern production methods that this natural product can be harvested, processed, and made available to consumers in such a relatively short time. As our newly packaged honey moves towards the warehouse, ready for distribution, we can appreciate the journey it has undergone. From the industrious bees collecting nectar to the high-tech packaging lines, every step has been optimized to bring nature's sweetener to your table. But our honey's journey isn't quite over yet. There's still one final stage to explore: the complex distribution network that will carry these bottles to stores across the country and beyond. You might think that once honey is bottled, it's a simple matter of shipping it to stores. But the reality is far more complex and fascinating. Imagine a chess game played out on a national scale, where every move of our honey is calculated months in advance. Welcome to the world of honey distribution, where cutting-edge technology meets age-old challenges. As our freshly packaged honey leaves the production floor, it enters a vast and intricate distribution network designed to connect this single facility to retailers across the entire country. This network is a marvel of modern logistics, comprising warehouses, distribution centers, and a fleet of vehicles ranging from large semi-trucks to local delivery vans. The first stop for our honey is the facility's on-site warehouse. Here, pallets of honey bottles are stored in climate-controlled conditions, awaiting their journey to various destinations. Temperature control is crucial at this stage and throughout the distribution process. Honey is surprisingly sensitive to temperature fluctuations, which can affect its texture and crystallization rate. Ideally, honey should be stored between 70–80 degrees Celsius (21 to 27 centigrades) to maintain its quality and prevent premature crystallization. Transporting honey presents unique challenges. Unlike many food products that require constant refrigeration, honey needs to be protected from extreme heat and cold. The trucks used for long-distance transport are equipped with temperature monitoring systems to ensure the honey remains within the optimal range throughout its journey. This is particularly important when shipping honey across different climate zones, from the heat of southern states to the cold of northern regions. But temperature isn't the only concern. The sheer weight of honey poses another logistical challenge. A single pallet of honey can weigh over a ton, requiring specialized handling equipment and careful load planning to ensure safe and efficient transport. At the heart of this distribution system is a sophisticated demand forecasting model. This facility doesn't just react to orders, it anticipates them. Using historical sales data, seasonal trends, and even weather forecasts, the distribution team can predict honey demand months in advance. This foresight allows them to optimize production schedules and ensure that the right amount of honey is available in the right places at the right time. The scale of distribution from this single facility is staggering. On any given day, trucks loaded with honey depart for destinations across all 50 states. Some bottles will end up on shelves in small local groceries, while others will be part of massive shipments to national retail chains. The facility's reach extends beyond domestic markets too, with a significant portion of its production exported to international markets. This extensive distribution network has a profound impact on the honey market. By efficiently connecting large-scale production with a wide range of retailers, the facility helps maintain a stable supply of honey across the country. This stability benefits both consumers, who can reliably find honey on store shelves, and beekeepers, who have a consistent outlet for their product. As we track a single bottle of honey on its journey from this facility to a store shelf, we gain a new appreciation for the complexity behind this seemingly simple product. From the careful temperature control to the precise timing of deliveries, every aspect of distribution is optimized to ensure that the honey reaches consumers in perfect condition. Our honey's journey, which began with a single bee visiting a flower, is now nearing its end. As it sits on a store shelf, waiting to be chosen by a consumer, it represents the culmination of an incredible process that blends nature's ingenuity with human innovation. But this end is also a beginning, as each bottle of honey holds the potential to sweeten meals, soothe throats, and connect people to the fascinating world of bees and beekeeping. As we conclude our exploration of honey production and distribution, we're left with a deeper understanding of the effort and expertise that goes into every golden drop. From hive to home, the journey of honey is a testament to the intricate dance between nature and technology, a sweet reminder of the wonders that surround us every day. As we've seen, modern honey production is a remarkable blend of nature's ingenuity and human innovation. From the tireless work of bees to the precision of industrial-scale processing, every step is optimized for efficiency while preserving the essence of this natural wonder. Looking ahead, the honey industry faces significant challenges. Climate change, habitat loss, and pesticide use threaten bee populations worldwide. The future of beekeeping and honey production will likely depend on sustainable practices and increased efforts to protect pollinators. Next time you drizzle honey on your toast or stir it into your tea, take a moment to appreciate the incredible journey it's been on. That golden drop represents not just the work of countless bees, but also the dedication of beekeepers, the precision of food scientists, and the intricate logistics of modern distribution. It's a testament to the sweet harmony between nature and human ingenuity,